Hi everyone, welcome to this demo about modern data engineering with Databricks. Imagine you're asked to build a system that uses machine learning to monitor if users on Twitter talk about your company and your products in a good or bad way. Of course, before we even think about the ML model, we need to make sure we have good data for it. And that data comes from quality data engineering with pipelines and workflows. Let's look at how we might construct that. To connect to a live Twitter feed, I use a Databricks Python notebook backed up by a Git repo. With the Tweepy API, I define a search expression for my stream. That data will be streamed into an S3 bucket. Delta Live Tables, DLT, is the modern way to do ETL on the Lakehouse. I'm using DLT to ingest, cleanse, and transform those tweets. You can do that entirely in SQL, but we also support Python for DLT in case you prefer that. DLT data pipelines are declarative. The Lakehouse platform provisions the underlying autoscaling infrastructure, creates the tables, and figures out which tables have to be updated in which order. Following the medallion pattern, where data quality is improved going from bronze to silver to gold tables, I describe my first live table in SQL, the bronze table. It's a table that uses autoloader for ingestion. Note the keyword live here. With autoloader, data ingestion becomes as easy as dropping files into a folder. Autoloader is using this directory. It can infer the schema, which is a convenient and time-saving feature since every tweet consists of more than 40 different attributes. Now, thanks to autoloader, I don't have to manually map all those column names and types to table schema. From now on, I can rely on the bronze table with a proper schema. Autoloader itself is a streaming data source, so a single tweet will be ingested exactly once, and I can create a streaming live table. Streaming live tables are stateful. They work incrementally and remember what state was processed already. My second live table, the silver table, depends on the bronze table. This silver table drops the rows with unsuitable data. It also removes unnecessary columns from the data coming from the bronze table. The goal is to create data fit for the ML model. To ensure data quality with DLT, I can use a feature called expectations. An expectation is a constraint with an action to take based on a condition. For this use case, I make sure that I only use English tweets because my ML model was trained with English text only. All the other tweets will be dropped. A third table in my pipeline computes a simple histogram of all the different languages in the tweets, because that's something I'm curious about. For the running pipeline, I can see the lineage graph. Here, I trigger the pipeline manually. If I run it again, it will only read the tweets that arrived since the last run. Under pipeline settings, I could set the pipeline to continuous mode to keep it running and reduce latencies. Here, I can also enable enhanced autoscaling, which is improving the throughput and therefore reducing the cost while keeping the latency low. The target setting allows me to run the exact same pipeline in development, staging, or production environment. Finally, in my third notebook, I use a Hugging Face transformer. That's a pre-trained ML model for sentiment analysis that even understands about emojis in tweets. The cleaned Twitter stream, that is the output from the Delta Live tables, is the input for my ML model. It's a Delta table. The final output shows a pie chart assuring me that like 93% of all tweets are either positive or neutral, and a word cloud displays the most frequently used words in those positive tweets. The ML model shows that we're good. People love Databricks, DLT, and workflows. Obviously, you do not want to juggle with all these notebooks yourself, but use Databricks Workflows, the fully managed orchestration service which is built into the Lakehouse platform. For my use case, I orchestrate 3 separate tasks. The Python notebook that reads the Twitter feed, a data pipeline built with DLT to prep the data for ML, and the notebook running Hugging Face for sentiment analysis. If I try and add another task, you can see that there is a vast selection of different task types that can be orchestrated, such as jar files with a main class, Spark jobs, Python scripts and Python wheel packages, as well as data flow pipelines in DLT or DBT. Once my job is scheduled and running, I'd like to get some insight whether it executes without any failed tasks. I can look at all the runs. And speaking of observability, my favorite view is the matrix view that shows me the jobs over time. So long-running jobs and errors can be spotted easily. If an error occurs, I can use the repair and rerun feature to rerun all the downstream tasks that were impacted. This saves significant time and costs. Hopefully, now you've got a good idea of how to build a streaming data pipeline with Delta Live tables and orchestrate all data engineering tasks with Databricks workflows. With modern data engineering on Databricks, you can easily ingest and transform batch and streaming data.